Welcome to Mastering Python Property Decorators. We'll explore how A.property can transform your code into a more Pythonic and maintainable form. This guide will cover the fundamentals, implementation patterns, validation, computation, advanced techniques, and best practices. Property decorators in Python allow for cleaner code by managing attribute access. They enable validation, computed attributes, and encapsulation without altering the API. This approach contrasts with direct attribute access, which lacks validation and flexibility. Understanding these decorators is crucial for writing robust, maintainable Python code. Direct attribute access in Python is straightforward, but lacks flexibility. It doesn't allow for validation or logic without altering the API. For instance, setting a negative radius in a circle class is possible without checks, leading to invalid states. This approach limits adaptability when requirements evolve, necessitating a more robust solution. Property decorators in Python allow you to execute code when accessing attributes, maintaining the simplicity of direct access. The property decorator turns a method into a managed attribute, enabling validation, computation, or logic without altering the API. This approach embodies Python's philosophy of starting simple and adding complexity seamlessly. The property decorator in Python transforms a method into a getter, allowing attribute-like access while executing underlying logic. The method name becomes the property name, accessed without parentheses, and returns the value. By default, properties are read-only, as seen in the circle class example, where radius is accessed directly, but cannot be set without a setter. The setter decorator, aPropertyName.setter, allows controlled write access to attributes. It intercepts assignments, enabling validation or transformation. For instance, in the circle class, setting a negative radius raises a value error, ensuring data integrity. This pattern maintains the intuitive obj value syntax while executing validation logic. Deleters manage resource cleanup efficiently. In the resource class, the eConnection.deleter ensures that when a connection is deleted, it closes and nullifies the connection. This is crucial for releasing resources like database connections, clearing caches, or resetting states, ensuring optimal resource management and preventing leaks. Computed properties dynamically calculate values from other attributes, ensuring consistency and reducing memory usage. In a rectangle class, the area and perimeter are computed on the fly, eliminating the need for redundant data storage. This approach guarantees that changes in dimensions automatically reflect in the computed properties, maintaining accuracy without manual updates. Incorporating validation in setters ensures that all attribute assignments adhere to business rules. For instance, the temperature class enforces type and range checks, raising errors for non-numeric values or temperatures below absolute zero. This approach centralizes validation, providing a single source of truth, clear error messages, and preventing invalid states. Read-only properties are crucial for maintaining data integrity. By omitting the setter, attributes become immutable, raising an attribute error if modification is attempted. This approach is ideal for identifiers or computed values, ensuring they remain unchanged post-initialization. Explicit error messages further clarify why modifications aren't allowed, enhancing code readability and intent communication. In a user model, properties ensure data integrity and security. The email property validates format and normalizes input by lowercasing. The password property is write-only, preventing access to sensitive data by raising an attribute error. Passwords are stored securely as hashes, not plain text, ensuring robust protection against unauthorized access. Caching optimizes performance by storing results of expensive computations. In the data analysis class, the mean property calculates and caches the mean of data. If data changes, the cache is invalidated, ensuring accurate recalculations. This approach is efficient for operations like database queries or complex calculations, minimizing redundant processing. Deciding between properties and methods hinges on context. Use properties for quick, parameterless access to object state, ensuring idempotency. Opt for methods when operations need parameters, are costly, or have side effects. Gray areas exist, like database queries typically being methods, while cached computations might suit properties, and format conversions depend on their computational cost. The temperature class demonstrates dependent properties, where Celsius and Fahrenheit provide different views of the same data. Changing one updates the internal state, ensuring consistency. Only the Celsius value is stored, while Fahrenheit is computed, illustrating how properties can offer multiple interfaces for the same underlying data. Properties in inheritance allow subclasses to override getters, setters, or deleters, enabling specialization. In the shape class, the area property is defined but not implemented, enforcing a contract. Subclasses like circle and square provide specific implementations, ensuring flexibility while maintaining a consistent interface. In advanced property usage, private validation ensures data integrity. The bank account class uses a private method, validate balance, to enforce that balance is numeric and non-negative. This validation is invoked in the balance setter, ensuring all modifications, including deposit and withdraw methods, adhere to these rules, maintaining a clean and reusable code structure. The property function was the original method for creating properties in Python, offering a verbose approach. With Python 2.6+, the property decorator became the standard, providing a cleaner, more readable syntax. This decorator is syntactic sugar for property, making it the preferred, intuitive choice for defining properties in modern Python. Avoid infinite recursion in property methods by not calling the property itself. For instance, in a property method named name, ensure it doesn't return self.name. Instead, use a private attribute like self.name to store the value, preventing recursive calls and potential Stack Overflow errors. Data classes simplify object creation by generating methods like init, while properties add validation and computed values. In the product class, the discount property ensures values between 0 and 1, affecting the sale price calculation. This combination allows for efficient, error-checked data handling, as seen when setting a discount of 0.2 results in a sale price of 800.0. Testing properties ensures reliability. Validate with unit tests. Check for value error on invalid radius. Confirm area calculation accuracy, and verify area updates with radius changes. Properties are integral to your API, requiring thorough testing to maintain functionality and integrity. Properties in Python don't appear in by.dict.r by default, complicating serialization. To serialize properties like radius and area, use a method like toDict. This method explicitly exposes desired properties, ensuring they are included in JSON serialization. For instance, Circle's toDict method captures both radius and area, enabling accurate JSON representation. Lazy loading defers resource-intensive operations until necessary, optimizing performance. Computed aggregates dynamically calculate summaries, ensuring data remains current. Format conversion offers diverse data representations, enhancing flexibility. Backwards compatibility maintains functionality by allowing attribute renaming without disrupting existing code. These design patterns enhance API efficiency and usability, ensuring robust and adaptable systems. Ensure property getters are fast and side effect free. Use methods for costly operations. Validate data in setters to catch errors early. Maintain consistent naming with underscores for private attributes. Document property behavior with clear docstrings, detailing representation, validation, and computation. This enhances code clarity and reliability. Properties introduce minimal overhead, typically 50-200 nanoseconds, compared to direct attribute access. This is negligible for most applications. However, in performance-critical scenarios like tight loops or real-time systems, direct access may be preferable. Always profile before optimizing, as premature optimization can degrade code quality without tangible benefits. Properties embody Python's philosophy by allowing simple attributes to evolve with added logic, maintaining API stability. Setters enforce business rules centrally, ensuring data integrity. They expose computed values without redundant storage, keeping objects efficient. Opt for properties over methods for clear design, as they offer control with simple syntax, enhancing code clarity and maintainability.